I'm fine, Rakshit. Thank you for asking. Today I'm not feeling well, health-wise. Okay. So that's my voice is a bit low, but we have to study. So that's why I'm here. So in the previous lecture, basically what we have did is uh, alternating current. We have started, and we have learned something like what is the RMS value of current, what is the average value of current. ठीक है. Alternating current, what is actually alternating current is, how does it differs from the direct current. All of the classification we have seen, how many types of alternating current we can have, and what is the condition for a current to be alternating. So these are the topics, these were the topics that we have discussed in the previous session. Are you aware about that? Any doubt in this? My voice is coming to all. Son. Okay. चलिए तो फिर. हाँ. So in the previous session, what we have seen कि उसी का ही ये एक revision type of thing. So we have seen that when current having a value of I naught sine omega t type of value, because we know कि this sine omega t is a periodic function which changes its value with the time period. For different time, this function will have a different value, and we can also say that this function also varies in a positive and negative manner. Okay, for first half it will be positive, for second half it will be negative. So it is qualifying the condition for a current to be alternating. Okay, we know that for a full cycle the value of the alternating current is 0. The peak value here represent I naught sin omega t, and this RMS value is given by root mean square value, which is nothing but peak value divided by root I naught by root 2. But this I naught by root 2 for full cycle. Okay. But if a function like this came into the picture, I naught sin omega t into cos omega t is equals to I naught by 2 sin 2 omega t, because we have multiply and divided by 2. This will become 2 sin 2 theta formula. Sin 2 theta is 2 sin theta cos theta. Similarly, sin 2 omega t will become sin omega t into sin omega t into cos omega t. So for this function, you need to make it either in a cos form or in sine form. So here we have make it in sine form. So for this also, average value is always 0. Peak value is I naught by 2, as you can see in this expression. And RMS value will be I naught by 2 into root 2, because RMS value is nothing but the I max divided by root 2. Angular frequency is always given by this omega. So here it is omega. Here this will doubling its value, which is 2 omega. So here it is 2 omega. Then I3 is equals to I naught sin omega t plus I naught cos omega t. This may be what we will do. We will change it. We will apply the formula here. We will take I naught as common, and then we will apply the formula. Okay. So when you do so, you will find that alternating current ka peak value is coming out at root 2 I naught. So RMS value will become I naught by root 2 into root 2. This root 2 and root 2 cancel out. So here the value of RMS is I naught only, and angular frequency does not change. So for above varieties of colors, current RMS is peak value by root. Okay, this is the formula. Now, some more important waveform and their RMS and average value. So first of all, sinusoidal wavelength के लिए, this is the sinusoidal wave, the variation of y is equals to sin x. ठीक है, but here it is given as I is equals to I naught sin omega t. So this is kind of graph is sinusoidal graph. One half is positive, other half is negative. This type of value has RMS value I naught by root 2 and average value for half cycle. Okay, एवरेज वैल्यू फॉर हाफ साइकिल है, क्योंकि फुल साइकिल के लिए एवरेज वैल्यू तो जीरो हो जाए, तो दिस इज फॉर हाफ साइकिल. यू शुड मेंशन इट हियर फॉर हाफ साइकिल. हाफ वेव देखो, one wave is here only positive side, then zero current, then positive. So this type of pattern is half wave rectified. Okay, we will see when we study the electronics physics or semiconductor physics. In that chapter we will see rectifiers, or then you will get to know what is a half wave rectifier and how to get it. Okay, but till now you will remember this pattern as a half wave rectifier. RMS value of this function is I naught by 2, and here average value is I naught by pi. Okay, now full wave rectifier, so that gap has been vanished now. This positive, when it is finishing, next positive is being created. This is a full wave rectifier. Again, the peak value, the RMS value is I naught by root 2, and this is the average value for half cycle. Square and rectangular form. So this type of form is, this is also alternating current, but this current is not alternating. Okay, because other side is not getting negative, only positive current we are having. Okay, this is a kind of alternating current because one half is positive, one half is negative. So for this, the RMS value is I know and average value is also I know. This is a pattern. Next pattern is sawtooth wave. So this sawtooth wave is nothing but if you have see a hexa, it is like this. I have drawn it invertly. So this is a kind of hexa tooth. This pattern is look similar to the tooths of hexa. So that is why we say it as a sawtooth wave. So RMS value of this is I naught by root 3 and average value is I naught by 2. Okay, you can note it down. Now, based on that, let's just solve this question. An AC voltage is given by V naught plus V1 cos omega t. What is the RMS value of one cycle? Again, for RMS value, what we will do? VRMS is nothing but square root of integration 0 to t by 2, sorry, 0 to t and V square dt divided by 0 to t dt. Clear है? So by applying this formula, we can calculate the value VRMS. Now we know the V naught is here is given as V is equals to V naught plus V1 cos omega t. Okay. Now this, either you can take it as square of it. V equals to V naught. Just a second. V is equals to V naught V1 cos omega t. So here we can say V square is nothing but V naught plus V1 cos omega t whole square. So it is V naught square V1 square cos square omega t plus 2V1 cos omega t. Okay. So if you see here, for complete cycle 0 to t, we have seen that this trigonometric function will become 0. So only function you need to integrate is V1 square cos square omega t. Okay. And for a complete cycle, V1 square is what? V1 square is a constant term. So 0 to t cos square omega t dt. Now cos square omega t ko you can write what? 1 minus 2, sorry, 2 cos 2 omega t minus 1 divided by 2. I have told you in the previous class how to convert it. This is nothing but cos 2 theta in the form of cos. So this is 2 cos square theta minus 1. Then it will become, sorry, this 2 will not come. Cos 2 theta minus, sorry, plus 1 is equals to 2 cos square theta. So cos square theta from this equation will become cos 2 theta plus 1 divided by 2. Okay. So it is cos 2 omega t plus 1 by 2 we can put here. We know that integration of this, just a second, v1 square integration 1 by 2 dt plus integration 1 by 2 और ये v1 square कॉमन है 0 to t 0 to t cos 2 omega t dt. ठीक है. Cos 2 omega t का differentiation will become sin omega t sin 2 omega t divided by 2 omega 0 to capital T. ठीक है. So this will become sin 2 omega capital T divided by 2 omega plus T by 2. 0 to T is T. 1 by 2 multiply by T is T by 2. Now you can put the value of T in terms of omega here or omega in terms of T, whatever you want to do. If you put omega is equals to 2 pi by capital T, so here this will become sin 2 omega T, 2 pi by capital T. Sorry, ओमेगा की वैल्यू पुट कर रहे हैं ना, sin 2 into 2 pi by capital T into T. This and this will cancel and this will become sin 4 pi, which is nothing but 0. So this term will ultimately become 0. Only this term is remaining. Multiply by v1 square. ठीक है. So all we have done for v1 square cos square omega t. But integration तो इसका भी होगा ना, v naught square का. So it is also will become v naught square into t by 2 plus v1 square by 2 into capital T. So what we can do, the VRMS value here is t by 2 v naught square plus v1 square. Okay. So this is a kind of questions you can expect in your examination. Not exactly like this, but similar to. Now this one. The current flowing through a resistor capital R varies as I is equals to KT, where K is the constant. Find the RMS current for first 2 seconds. So here we have I is equals to K into T. Got it? And we have to find out the value of RMS current for 2 seconds. देखो यहाँ पे we cannot apply use the same formula. We have to integrate it because here the current expression is given in a different way. So we can say that IRMS, again the root formula is same. Is it square root of I square root of 0 to capital T I square dt 0 to t dt. Now firstly calculate this term separately. So it has become 0 to t k square t square dt. Okay, k square you can take common. This will become t square dt, and limits are 0 to capital T. So this will become k square into capital T square by, ठीक है, t cube by 3, because t square का integration will result in t cube by 3, ठीक है, so it is k square into t cube by 3, this term only. So IRMS is equals to integration of what? We can directly put this value, k square t cube by 3 into t. T and t will cancel out, so it will become kt upon root 3. This is the value of IRMS. Got it? अब देखो, what it is been asking, find the RMS current for first 2 seconds. So first 2 seconds के लिए t you need to put 2 here. So IRMS will become 2k upon root 3. Clear है? Any doubt in this case? Bishan, JNV, Rowing, Madhukar, any kind of doubt in this? If you have any kind of doubt, you can ask. Now the question arises that who can measure AC? Alternating current को measure कौन करेगा? To measure the direct current, we use galvanometer, we use ammeter. Clear है? So how to measure alternating current? देखो, moving coil galvanometer will work on the principle of magnetic effect of current, but magnetic effect of current is only exist for a direct current value. If the current is changing its polarity, then the magnetic field produced by it will also changing the polarity. So if you attach the moving coil galvanometer to AC, it will either burst out or show you the negative results. So you are fluctuating result like this. So what to do? We can see that the current flow in any wire will produce a heat effect. Okay. So the instrument that used to measure AC is termed as hot wire. And what is the principle? Principle is heating effect of current. Okay. DC meter में moving coil galvanometer we will use. Okay. Based on the magnetic effect of current. What does it reads? It reads the average value of the current. And what does AC meter read? It reads the RMS value of the current. If used in AC circuit, then they read 0. Average value of AC is 0. Deflection is directly proportional to current, which is phi directly proportional to I. इसका मतलब क्या हुआ? देखो, ऑन एन एवरेज ये एवरेज वैल्यू मेजर कर रहा है, एंड ऑल्टरनेटिंग करंट का फुल साइकिल में एवरेज वैल्यू इज 0. So that is why we cannot use this DC meter to measure AC current. Okay, alternating current. Clear है? In AC meter, AC और DC दोनों पे काम करेगा, बिकॉज AC करंट भी हीट प्रोड्यूस कर सकता है और DC करंट भी हीट प्रोड्यूस करेगा. ठीक है, सो इट वर्क्स ऑन बोथ. बट द वेरिएशन, जो डिफ्लेक्शन है निडल का, इज नॉट लीनियर इन दिस केस. ठीक है, सो because it is a RMS value, or RMS value is I naught by root. So it is not a linear variation in this, which means if you will see DC meter, you will see the reading like 1, 2, 3, 4, 5, equal separation. But if you will see the AC meter, the units are not equal. It's like this. It's a non-linear progression. Clear? So you need to remember that on which principle this AC and DC meter work. What is the name of instrument? Clear? And what does it read? So AC meter read RMS value, DC meter read average value. AC meter uh, is based on heating effect of current. DC meter is based on the magnetic effect of current. Name of AC meter is hot wire. Name of the DC meter is moving coil. Now, hope you understand that this is the factual knowledge. So I'm not much pushing you towards the learning of the factual knowledge. I just push you towards the conceptual knowledge. Now here we have a very good concept to understand the basic circuits and the combination of circuit and alternating currents. The concept of phasor. So phasor is nothing but if you have learned something about the complex number, so it would be very easy to understand that. Okay. Because a complex number, if you have learned complex numbers, is given by 4 plus 3 iota, let's say, or let's say very general value, which is a plus b iota. So we can treat this complex number as a vector of magnitude modulus of z, which is root a square plus b square, and angle as the argument of this complex number in Argand plane, which is tan theta is equals to b upon a. Got it? In a similar way, if you will see the value of current and value of value of EMF, let's say V is equals to V naught sine omega t. So this value is being fluctuating between 0 to minus and 0 to plus. But for a certain point of time, or if you want to calculate the peak value, it is nothing but the V naught. Okay? The magnitude of this voltage will depends on the time period, will depends on the value of time at that instant. So that is why what we are doing, we are creating a oscillating vector, okay, which tells us about the magnitude of a oscillating quantity for a particular time instant. As the time instant changes, the magnitude of this vector will also change. Okay, clear? Or we can say the fluctuation is possible in these types of vector. So phasor is a vector rotating in anti-clockwise sense. So it's a rotational vector, okay, which rotates in anti-clockwise sense with angular velocity omega, represent the angular frequency of the oscillating quantity. Omega क्या है? Angular frequency of the oscillating quantity. जो लेंथ होती है ना फेजर की, the length of the phasor is equals to the peak value of alternating current. So peak value, let's say V is equals to V naught sine omega t. If this is a kind of phasor, if we want to introduce phasor by this quantity, so this V naught will be the peak value, okay, of this alternating quantity. Okay. Now at any instant, the angle made by phasor with plus axis means positive x-axis, represent the phase of the oscillating quantity. Now phase, what is phase actually? If I just elaborate on this more, phase of a phase of oscillating quantity, oscillating quantity. So if a oscillating quantity is like this, y is equals to function of x and t. The phase of this quantity, let's say phi, represent the status of this quantity. Status of this, status of y is equals to fxt, xt at a particular instant. Suppose we are provided with a sinusoidal wave, which is nothing but y is equals to sine a sine omega t. Let's say a sine omega t. This quantity is varying with like this. The peak value that this quantity has is a, because sine omega t peak value is 1. 1 into a is a. Okay. So this y is keep oscillating between minus a to plus a, because sine theta or sine omega t will always varies between minus 1 to plus. This is the range of sine function. Okay. Now what is phase in here? Let's say at a particular instant of time we are here and we want to calculate what is the magnitude of this particular function y at this particular time. So it can be known by only phase, because phi here is nothing but this omega t na is nothing but phi. So at a particular instant, what should be the value of, what will be the value of y will be decided by this omega t. Okay. Will be decided by this omega t. What is the time at that particular instant? So for example, if t is equals to 0, this a sine omega t will become a sine 0, which is 0. And at t is equals to capital T, a sine omega t will become a sine omega की वैल्यू 2 pi by capital T into capital T cancels. Cos 2 pi will become what? Sorry, sine 2 pi will become is sine 0. So when the time changes, the value of this y function is changing, or this oscillating quantity is changing, which means this phase represents the status of this particular, of any particular oscillating quantity for a particular time, for a specific time. किसी भी टाइम पर कोई भी ऑब्जेक्ट किस पोजीशन पे है, कोई भी ऑसिलेटिंग वेक्टर का मैग्नीट्यूड कितना है, वो किस एंगल पर है, that all information or especially the status of that particular object is given by phasors. ठीक है, क्लियर? अब देखो, नाउ चलो एक काम करते हैं, इन्हें ऐसे समझते हैं। एक मेरे पास अभी हम ऑल्टरनेटिंग करंट पढ़ रहे हैं, तो ऑल्टरनेटिंग करंट से ही से समझेंगे, ठीक है? We have taken an example of I is equals to I naught sin omega t. Now how to convert this function as a phasor diagram? ठीक है, तो कैसे कन्वर्ट करेंगे? तो सबसे पहले आपको एक प्लेन बना लेना with positive x axis and positive y axis, negative x and negative y. Clear है? Now you need to draw a length of arrow like this, and this length, what is the length? This is nothing but a phasor of current. ठीक है, so here this particular angle, sorry, this particular quantity represent, this length represents what? I naught, because the length of the phasor is equals to the peak value of alternating quantity. Okay, so here the length of the phasor is I naught. Okay, and what is the angle? To draw a vector, we need two things: the magnitude of the vector and the direction of the vector. So to draw a phasor, we need also two quantities: the magnitude of the phasor and the angle of the phasor. And angle is nothing but this omega t. So this particular angle is omega into t. This is a phasor of current. Okay, let's say we have another example. I is equals to I naught sin omega t plus phi. नाउ अब देखो फेज कितना बढ़ गया, फेज का एंगल कितना बढ़ गया, फाई एंगल बढ़ गया। तो सेम प्लॉट पे अगर मैं इसी प्लॉट पे बनाऊं ये विद आई नोड एज अ लेंथ, आई नोड चेंज नहीं हो, ठीक है? सो इट विल बी स्लाइटली अप, एंड दिस पर्टिकुलर एंगल is termed as omega t plus phi. Clear? So if I define here the phase difference. So phase difference is what? The difference in the angle between them. ठीक है, so it is omega, या हम कह सकते हैं phi final minus phi initial. और phi final कितना था? ओमेगा टी प्लस फाइव. इनिशियल कितना था? ओमेगा टी. ये कैंसिल आउट, तो फेज डिफरेंस इज कमिंग आउट एज ओमेगा. क्लियर है? अब देखो, नाउ डू सम एग्जांपल्स ऑफ आई इज इक्वल्स टू आई नॉट साइन 2 pi by 3. ये हमारे पास वी हैव टू ड्रॉ आई नॉट बाई 2. ठीक है, सो आई नॉट बाई 2 किस वैल्यू पे मिलेगा फ्रॉम दिस फेजर? आई इज इक्वल्स टू आई नॉट साइन ओमेगा. So when the value of this omega t will become what? Pi by 3, pi by 6. So sine pi by 6 will become 1 by 2. Then at that particular instant time I की value कितनी बन जाएगी आपके पास? Sine naught by 2. So to draw this is I naught and this is pi by 3 for this particular value. ठीक है. But what if a current is represented by like this? अभी आपने सीख लिया ना. किसी को कोई डाउट है कैसे ड्रॉ करना है फिर? I is equals to I naught sin omega t minus 5. इसे कैसे ड्रॉ करेंगे? -5. So when the angle is minus, you need to turn the vector in from anti-clockwise manner to clockwise manner. So when phi is not present, let's say omega t is here. This is omega t. This is I naught. But we do not have to shift phi further. We have to shift phi here. Let me draw it in a very broad way so that you will understand it. This is I naught at omega t. Okay. Then we have to draw -5, which means we have to turn it in opposite manner. If it is +5, we have to move it like this. But if it is -5, we have to move it in opposite way at -5. So let's say -5 will come here. This is -5. So that is why this angle will become omega t minus 5. Clear? So I hope you are clear with the drawing of this phasor diagrams. क्लियर हो आप सभी? फेजर डायग्राम कैसे ड्रॉ करते हैं? ठीक है. सो दिस पर्टिकुलर इंस्टेंट पे एट ओमेगा टी प्लस 5 और ओमेगा टी माइनस 5, प्लस 5 कहाँ पे होगा? लेट मी यूज अनदर कलर. ओमेगा टी प्लस 5 होगा यहाँ. दिस एंगल इज ओमेगा टी प्लस 5. क्लियर है? अब देखो तीनों एंगल आ गए. तो ये क्या बता रहा है एट पर्टिकुलर इंस्टेंट? ये वाई एक्सिस पे क्या बताता है? इफ यू ड्रॉ द प्रोजेक्शन ऑफ दिस वेक्टर ऑन वाई एक्सिस, it will tell you what is the amount of that particular oscillating quantity at that particular instant. So if I want to calculate the magnitude at omega t minus 5, so I have to draw the projection of it, and this value represents I naught sine omega t minus 5. This is the magnitude of this particular oscillating quantity at this particular instant. Okay. So I hope that this would be very much clear to you how to draw them. ठीक है. अब देखो मैं आपको एक सिंपल सा फेजर डायग्राम ड्रॉ करके दिखाता हूं जो है फॉर अ प्योरली रेसिस्टिव सर्किट. आप देखो यहां से भी देख सकते हो. ये एक रोटेटिंग वेक्टर है. फॉर एग्जांपल हमारे पास आई इज इक्वल्स टू आई नॉट साइन ओमेगा टी प्लस पाई. ठीक है. क्लियर है? नॉट प्लस पाई ओमेगा टी रखते हैं. तो ये देखो ये वेक्टर क्या है? ये रोटेट कर रहा है ना. जैसे जैसे ओमेगा टी की वैल्यू इंक्रीज हो रही है या चेंज हो रही है, दिस वेक्टर का मैग्नीट्यूड denoted by this point which is oscillating in this manner for a particular instant of time. If this vector is at this position, this is the phase angle omega t, and this particular value projection on the y-axis is same as the value of sinusoidal wave. देखो sinusoidal wave ऐसे वेरी कर रही है, तो इस पूरी sinusoidal wave को we have converted into a this rotating vector. ठीक है. अब इस साइनोसोडल वेव का इस पॉइंट ऑफ टाइम पे व्हाट इज द मैग्नीट्यूड? सो यू नीड टू पुट दिस वैल्यू in this expression and you will get this value. In similar way, if you get the projection of this vector on y-axis, this will be the magnitude of this vector at y axis at this particular time. क्लियर है? किसी को कोई डाउट है? एनी काइंड ऑफ डाउट? क्लियर? अब देखो ओमेगा टी की मैक्सिमम वैल्यू कब होगी? एट पाई बाई टू, 90 डिग्री पे. सो एट पाई बाई टू दिस विल बिकम आई नॉट. अब देखो ये वेक्टर भी पाई बाई टू, यानी कि इस पर्टिकुलर पॉइंट पे ही तो जाकर के क्या हो रहा है? गिव मी अ सेकेंड. इस पर्टिकुलर पॉइंट पे जाके ही तो, या तो ये वाला देख लो आप या ये वाला देख लो, इट इज बिकमिंग मैक्सिमम at 90 degree. If you will see it rotating. Okay, so this particular angle is 90 degree, and at 90 degree it is getting its maximum value. Either you see in this graph and you see in this graph. Okay, so I hope this is very much clear to you. ठीक है, यहाँ से भी आप कह सकते हो सेम चीज. ये I इज इक्वल टू आई नॉट साइन ओमेगा टी. ये लेंथ हमेशा आई नॉट ही रहेगी. ठीक है, वेरी क्या करेगा? वाई एक्सिस पे मैग्नीट्यूड. देखो वेरी कर रहा है ना. This dot is moving up and down, which means magnitude is varying. Now AC voltage applied to a resistor. ये हमारे पास एक सर्किट है जिसमें R रेसिस्टेंस लगा हुआ है. We have placed a resistance R here. V is equals to IR, and voltage applied is E is equals to E naught sin omega t. Okay. We are representing voltage here as EMF. Okay. So what is the procedure now? How to get the current expression so that we could compare it with the potential difference over the voltage. So we know that V is equals to, here E is given. So E is equals to E naught sin omega t. Okay, this is equation number 1. We know that according to Ohm's law, Ohm's law is given by V is equals to IR, and since V is given by E here, so it will be E is equals to I into R. ठीक है, E की वैल्यू पुट करो, E नॉट साइन ओमेगा टी equals to I into R. I is equals to E naught upon R sin omega t. ठीक है, if R is, sorry, firstly we will write E naught by R. E naught by R is nothing but the maximum value of voltage divided by the resistance, and the value of resistance will not change, which means it is nothing but the maximum value of current. So it is I naught sin omega. Okay. अब आप लोग मुझे बताओ, any one of you, if E naught is the maximum value of EMF or voltage, and I naught is the maximum value of current here, which one is greater? Either E naught is greater than I naught or I naught is greater than E naught. Tell me in the chat box. Look, it will depends on the value of R. If R is greater than 1, okay, then this value is reducing. If something is divided by with a greater value than 1, then that particular resultant value will decrease. Very good. Very good vision. But if resistance having here is the value is less than 1, then we can say this particular magnitude of current will increase. Because let's say R की value हमारे पास 1/2 ohm है, then E naught divided by R, which is 1/2. So it is becoming 2 E naught, which means the current की value is great. ठीक है, clear है? So less resistance, more current will flow. We know that simple law है. क्लियर है? अब देखो हमारे पास दोनों इक्वेशन है, दोनों को फेजर बना सकते हैं, ई को भी फेजर डायग्राम में कन्वर्ट कर सकते हैं. और हम ये क्यों कर रहे हैं? बिकॉज ई और आई क्या है? ऑसिलेटिंग क्वांटिटी. और फेजर के अकॉर्डिंग फेजर कौन सी क्वांटिटी है? ठीक है। फेजर कौन सी क्वांटिटी है भाई? फेजर क्या है? एक रोटेटिंग एंटी क्लॉकवाइज सेंस में, ठीक है। ऑसिलेटिंग क्वांटिटी, ऑल्टरनेटिंग क्वांटिटी, किसी भी ऑल्टरनेटिंग क्वांटिटी को ही तो हम फेजर बोल रहे हैं, ठीक है। और ये दोनों क्या है यहाँ पे? ये दोनों क्या है? ये ऑल्टरनेटिंग क्वांटिटीज ही तो हैं, आई और ई। सो दैट इज व्हाई वी कैन मेक इट इनटू फेजर डायग्राम। इनका फेजर डायग्राम ड्रॉ कर सकते हैं। देखो अब ये फेजर डायग्राम मैंने ड्रॉ किया है, एंड लेट जस्ट अंडरस्टैंड कि हाउ आई हैव ड्रॉन इट। तो फर्स्ट ऑफ ऑल मैंने आपको क्या बताया था, एक प्लेन आपको बना लेना विद एक्स एक्सिस एंड वाई एक्सिस, ठीक है। फर्स्टली ड्रॉ वोल्टेज which is like this. Let's say this is the magnitude E naught up to here, the length of the vector. This is the length of voltage value or the EMF value E naught. And phase angle इसका कितना है? ओमेगा टी है। क्लियर है ये बात? नाउ वी नीड टू ड्रॉ आई। अब देखो आई और ई दोनों का फेज क्या है? सेम है, ओमेगा टी, विच मीन्स ये कौन से फेज में है? सेम फेज में। हम इसे क्या बोलेंगे? व्हेन AC voltage is applied, alternating voltage is applied to a resistor, ठीक है, then current will also be in same phase। क्लियर? देखो, लेकिन करंट का मैग्नीट्यूड तो कम है ना। वी आर टेकिंग हियर दैट R is greater than 1, देन करंट का मैग्नीट्यूड तो कम ही होगा। सो इसलिए ये लेस देन दिस इज रिप्रेजेंट। ये क्या है? ये, बट दोनों का एंगल सेम है इसलिए सेम ही प्लेन पे ड्रॉ कर दिया, ठीक है। अब इसका साइनोसोडल वेरिएशन कैसे ड्रॉ करेंगे वो भी समझ लेते हैं। साइनोसोडल वेरिएशन इज गिवन बाय लाइक दिस, ठीक है। देखो, ई एन आई दोनों साइन फंक्शन है, तो साइन फंक्शन जीरो से स्टार्ट, मैक्सिमम वैल्यू देन अगेन जीरो, दिस टाइप ऑफ वेरिएशन। बट व्हाट इज द ओनली डिफरेंस बिटवीन ई एंड आई? द डिफरेंस ऑफ द मैक्सिमम वैल्यूज। I naught is slightly lesser than in E naught. So that is why if you will see, this is I naught, which is slightly lesser than E. Otherwise, the variation is same. Time period is same. If you will see 0 to pi by 2, 0 to pi, and फिर again pi to 2 pi. This period is same, but the difference in between the maximum values. Clear है? So this type of variation you can show for the resistor. So we can say that current and voltage are in same phase। क्लियर? अब देखो इसके लिए हमें पावर, वी वांट टू कैलकुलेट पावर, पावर फॉर प्योरली रेसिस्टिव सर्किट, प्योरली रेसिस्टिव सर्किट फॉर एसी, ठीक है, द प्रीवियस केस के लिए। तो पावर को हम कैसे लिखते हैं? पावर इज नथिंग बट आई स्क्वायर आर, ठीक है। आई की वैल्यू यहाँ पे पुट करोगे आप, आई की वैल्यू पुट कर दो। तो देखो वैसे भी आप सिंपल से एप्लीकेशन है, V इंटू आई होती है इसकी वैल्यू। V की वैल्यू पिछले केस से ई नॉट साइन ओमेगा टी, और आई की वैल्यू भी क्या है? आई नॉट साइन ओमेगा टी। सो पावर हियर विल बिकम ई नॉट आई नॉट साइन ओमेगा टी इंटू कोस ओमेगा टी, सॉरी, साइन स्क्वायर ओमेगा टी, ठीक है। बट दिस इज अ वेरिएबल क्वांटिटी, सो वी हैव टू टेक द आरएमएस वैल्यू ऑफ दिस। क्लियर है? वी हैव टू टेक द एवरेज वैल्यू ऑफ पावर। सो पावर एवरेज के लिए अगेन यू विल गोइंग टू इंटीग्रेट इट फॉर 0 to t एंड 0 to t, ठीक है। 0 to t में साइन स्क्वायर ओमेगा टी की वैल्यू आती है हाफ। क्लियर? So here power is coming out as Im square I mean, which means I 2 I naught by pi, average value of I current, multiply by R divided by 2. This is the average value of power. Clear? यहाँ पे आप आई बार और आई आर एम एस को रिलेट भी कर सकते हैं। तो अगर आप पावर का फॉर्मूला आई आर एम एस की वैल्यू में चाहते हैं तो पी एवरेज विल बिकम आई आर एम एस स्क्वायर इंटू आर। ठीक है, क्लियर है? सो ये क्या है, आर एम एस का मतलब यहां से आपको समझना है। सपोज मेरे पास एक बल्ब है, इसे मैंने पहले ऑल्टरनेटिंग सोर्स से चलाया और फिर इस सेम बल्ब को मैंने डीसी सोर्स से चलाया। ठीक है, तो जो वैल्यू हीट डिसिपेशन की, क्योंकि पावर है तो हीट डिसिपेट हो रही होगी, हीट डिसिपेशन ऑल्टरनेटिंग करंट में जितना होगा ये एवरेज पावर के अकॉर्डिंग ही होगा। ये वैल्यू क्या है, सेम फॉर डीसी इफ द करंट फ्लोज इन डीसी इज आईआरएमएस। ठीक है, तो अगर आईआरएमएस करंट फ्लो करता है किसी डीसी सर्किट में, आईआरएमएस की वैल्यू का करंट, ठीक है, सो इट विल आल्सो प्रोड्यूस द सेम हीटिंग इफेक्ट एज प्रोड्यूस्ड बाय एन एसी करंट। ठीक है, क्लियर? So this is the power formula. Now we will be calculating it for inductive circuit, have AC applied to an inductor. या next class में करें बताओ? Although the time is coming up, what you will say? Should we complete it or guys? What do you say? We keep the discussion till here or we should? हाँ, ये जो प्योरली रेसिस्टिव सर्किट है, दिस हैज completed. ठीक है, if you want me to do with this inductive circuit I can do, otherwise because time is getting up. Time is up. Yeah, 16:58 is happening right now. Okay. So enjoy your day of Diwali vacations because for upcoming 2 to 3 days there will be no class. Okay. For the 31st, 1st and 2nd November. Okay. So Monday onwards से आपकी classes continue आएंगी. So happy Diwali in advance to all of you guys. Please stay safe while playing with cracker, and I'll just avoid the use of crackers. I would not recommend it at all. ठीक है, मतलब I would not recommend to fire up the crackers. Otherwise what you can do as an initiative, if someone have or someone don't have, I'm not considering that, you can lit 100 of this मिट्टी के दीपक जो होते हैं, you can lit them with pure desi ghee. So what it will do, it will uh, increase the amount of oxygen in the environment. When you burn the pure ghee, then it will produces oxygen somehow. So ultimately, the people who are not concerned about the safety of our environment, you guys play that role and you play as a safer, okay, as a environment saver. Okay, you can do that initiative. Clear? So I'm launching a poll for you. Please do answer in that poll for your attendance. And thank you, Rakshit. I'll just take care of myself. Thank you. Happy Deepavali to all of you. And stay safe, stay happy, stay healthy, and keep studying. If anyone has any kind of doubt, you can ask right now. Otherwise, the lecture is being over. Thank you so much for being attentive and being responsive. Bye bye. Take care.